Well, hello. Today we're going to be talking about major water quality issues in Northern Illinois and in the Midwest. So we're going to talk about water quality problems. We're going to talk about a lot of different ones over this whole week. So again, this will be kind of our guiding PowerPoint slides, and we'll be going over a lot of different issues when it comes to water quality. We're in what's called the glaciated region, so just so we're a little bit clear on that. So if we look at our map here, you guys can see like this little blue line here. This is the extent of our major glaciers that have occurred. We've had the Illinoisan, we've had a Wisconsin, we've got different ones, and so this is our glaciated area. And so we're going to be talking about water quality that's generally associated with this region. If you notice up in Wisconsin, there's this white spot right in there. Well, that's the unglaciated or driftless zone. You may have referred to if you've ever headed over to like Baraboo. You've headed west of there. That area didn't have glaciers. I'll go over some of the geology of that later on and talk about that. But that is an area that wasn't glaciated, and so it's actually kind of has some unique issues when it comes to water quality. So we're going to be talking about those in this lecture. So on the Blackboard site, I have put a link to both of these circulars. So USGS is United States Geological Survey. Just so you know that USGS is basically the data gathering aspect of our federal government. So our federal government collects data, and very high quality data about everything environmental. This can be from biological. It doesn't have to be just geology and rocks and anything, but it's also biological systems, our natural parks, our water quality. All of that is tied to USGS. Just so you know that in the city of DeKalb, over on Peace Road and I-38, it's on Pleasant, is our local USGS office that does Midwest groundwater quality and water quality issues around the Midwest. And a lot of the alumni from NIU work in that office over there. And so we're very critical, NIU is, when it comes to water quality in the Midwestern United States. So these two articles were written by different people within it. This one right here is this one here from the USGS's Water Quality of the Glaciated Area. I showed you what that glacial area was. And this is from 93 to 03. This was actually written by Kelly Warner. She is an alumnus from NIU. So this is a product of what NIU's education, go Huskies, can do for you. And then this one over here is about chloride and underlying our water systems. You are required to read the abstracts from both of these. There's an executive summary or an abstract for each one of these. Please go on there. You can download the PDF or you can read what that is, just so you know that. But feel free to look through them. They've got some great information, questions that you might have from off of this lecture today. You may be able to just open up one of these two, open up to that section and read through it. It's very well written. They're designed to be written for people like yourself to be able to read and to understand. So please look those over. If you have any problems with them, I can always send you the final PDF version. However, I just gave you the link to where they were on the USGS website. So we're really going to be focusing on pollution or contamination. This is my main passion in this world is groundwater contamination and pollution. And so what are we talking about? Well, I want to talk about today a couple different things, and especially regional issues. So we're going to talk about chloride, road salt. You know, we're finally past the time when road salt is, but during the winter time on campus, there was salt put everywhere. I mean, just chunks of it everywhere, so that it's there, it's on our roads. And so I'm going to talk about some of the issues associated with road salt. Some of our issues in this area when it comes to water quality issues is the idea of arsenic. So we'll show where those issues are. That's more up in the upper part of the state and up into Wisconsin. There's got some arsenic issues. And one of them is radium, and that's a problem here in DeKalb and with our drinking water. And so I will get back to you. We'll talk more about that one. But these are natural problems. These are related to the geology of the area, because the geology impacts a lot of the stuff we've been talking about. I hope you're getting that. That the geology of where you're located might impact your water quality, especially when it comes to arsenic and radium, and that's in there. One of the other things that we've got a major issue around here is agricultural issues, because because we are in an agricultural area, we're surrounded by corn and soybeans, that we have a lot of ag issues. So we have nitrates and phosphates that are getting into our water, causing eutrophication. We'll talk about that. But we'll also talk about pesticides and herbicides inside of our water supply, and talk about some of the main causes of those, such as like atrazine in our water, other issues like that. We'll talk about lead in our water. Now, one of the things that you may have heard about all about the Flint. I'll go over what happened in Flint, and I'll talk later on about what's going on in Chicago, Milwaukee, other cities like that. So we'll talk about those. Why do they exist? What can you do? If you're interested in this issue, what's going on with all that, and we'll spend some quality time talking about that. And last, we'll talk about different types of organic compounds that can be found in water. So NAPLS stands for non-aqueous phase liquid. So non-aqueous means it doesn't mix with water, it's a separate phase, and it's a liquid. So if you've ever made salad dressing and you've got oil and water don't mix, and the oil is lighter than the water, it sits on top, that is what we call NAPL, or non-aqueous phase liquid. They're separated from each other in there. Now, when they say they don't mix, they actually do. There is a certain amount of solubility oil has within inside of water, and we'll talk more about that. And we'll talk about organic pollutions that can get into our water supply. And the organics I'm going to be talking about is mostly gasoline spills. So we talked a lot about oil and gas in the first part of this class. We talked about BTEX, if you remember that, benzene, toluene, ethylbenzene, and xylene. We're going to be talking more about those, and we're also going to be talking about dry cleaning solvents and some of the issues associated with those. I'm hoping to be able to get to PFAS, which is a new contaminant, a new emerging contaminant. It's called the forever chemical because it's everywhere and it's an organic. We'll probably talk some about PFAS too. So we're going to be talking about all of these different things within inside of this lecture series right now. So let's start off with road salt because, well, it's finally spring and we're finally out of it, but the road salt that was placed over the winter is still having a lasting impact on our water and our water quality, and if you're into biodiversity, this can really impact it. We put road salt down, as you know, to lower the freezing point of the water. So salt works great when it is close to the freezing point of water, so if it goes below the freezing point, it'll keep it as water, as slush. If it gets too cold, like we've had, where there's days it's so cold, salt makes no difference on there. Salt also does add some abrasion to the road so that you add some grit onto there so that you don't slide on the cement or cars don't slide. So we put down a lot of road salt in order for public safety. So one question I usually get is, well, why can't we just put like gravel or dirt? Because gravel or dirt would also give us that grit that's on there. One of the advantages to road salt is because, as you all know, and we talked about halite earlier in the class, this is just halite, so you should remember how halite was formed and how we get it. One of the things that's great about halite is that if you put halite or salt, table salt, inside of water, what does it do? Well, it completely dissolves, right? So it goes away, okay? And so when we use road salt on our roads, we're expecting that the salt will dissolve inside of all of our waterways and it'll move away from the system. So with all of our sewer lines, if we put grit down like sand or rocks and stuff like that, as they start to wash off, they're going to clog up all of our sewer lines. Our sewer lines are already getting a D when it comes to F when it comes to maintenance of them. They need to be replaced. They can't handle so much grit going into them and still maintaining flow within the system. So we generally do not try to use sand. Now some areas can handle it, and it depends on how their systems are set up, but generally we just use road salt. So what happens to the road salt? So this is just a picture here. This is road salt over in Calumet Harbor. It gets shipped in, and so a municipality, a city, will have to buy road salt, and they have to guess how much road salt they're going to need for the year. And so they buy it at a certain rate, and they buy so much of it. And so if the winter is very mild and they don't use it all, they have a lot of left over, they hold on to it. Or if the winter's really bad and they didn't plan in the right thing, then they're going to have to pay at a new rate, which is much higher. So the cities try to balance that. They want to get to that right balance point between having enough on hand and not paying too much for the extra salt that they may or may not need. This is just a picture of off of 88. This is Morton Arboretum. And Morton Arboretum, so what happens with all that extra salt? Well, it does kill the plants and the trees that are nearby there. There are certain plants and animals that can handle the higher salts, but when we talk about this, it generally is not good for our system. So as the road salt goes into the little ditches next to it, the spillways, those retention ponds I talked about, it dissolves completely in there and it gets into our groundwater, and it moves with our groundwater. You can see this pulse of salt that comes into our waterways, and if we put in a series of wells along in here, we would see this pulse of salt move through the system and come out over here. And so this pulsing of this stuff, it goes into there, it affects the trees and the ecosystems that are right around the roads. Well, that can cause a major problem because all of these areas that are right around here might not be salt tolerant. They cannot handle their salt. They're not designed to be around salt. So a lot of amphibians can't handle it. Trees, so we'll get killing off of trees and stuff in those areas. It's interesting for me is, especially when I'm watching campus here, the crabgrass. If you ever notice, even if you're home, if your parents or you know people who put a lot of road salt down or put salt down on their thing, you'll notice that right along the edges of their sidewalk, you'll get a lot of crabgrass. And this happens every year at NIU. We get tons of crabgrass coming when the grass comes back up. And then Grounds goes through and removes all the crabgrass. They put new sod onto it. Well, they can handle the higher levels of salt. So they are pretty good about that. It's when you get the areas where the regular grass can't handle it. So crabgrass grows where there's higher salt concentration. So it's a constant battle for getting this together and keeping salt on there. So road salt, let's see. Put this up here. Road salt, 55% of the salt flows into our groundwater supply. The rest of it flows away with our surface water. It may increase the salt concentrations of our ground and surface water above established health lines. So we can't drink groundwater with too much salt. Most animals can't handle it. This really affects about 10% of the aquatic species are affected by prolonged exposures of greater than 230 milligrams per liter. So when we start getting into higher concentrations of it, it really affects our ecosystems. So if you're going into biodiversity and restoration projects, you might want to think about how road salt during the winter will affect you in the spring when it's dissolved and we're going around there. High concentrations can damage foliage, roots, sensitive plants, wetlands, so we have to be careful. This is always an example I like to show. What it was the salt levers. This is Lake Leopold up in Prairie Crossing. So up until 2000, there really wasn't a lot of salt put down. Then the city of Grays Lake took over road maintenance in 2001, and they started doing tons of salting because they're afraid for cars sliding, public safety issues. And you can see how the concentrations, especially in 2001, exceeded that 250 milliliter per gram. The 230 thing right after they took over. And also, like, roadside wetlands have very high concentrations of road salts versus natural wetlands have very low concentrations. And again, that 230 maximum level. So roadside wetlands, so if you're thinking about where a wetland could be, we're just going to maintain this wetland, but we're going to put roads and major roads with lots of salt right through them or next to them, you're going to impact those things. And since salt is completely dissolved in water, it moves with the groundwater. It just moves with this, so it can affect areas that are down gradient from that salt. It doesn't just stay right where it's at. It's going to move, and it's going to go through the spring semester. Through the spring and into the summer. And that pulse was not just like, it put it on and it's gone. This is a major problem with Chicago. So we talked about Chicago and we talked about recharging into the Great Lakes. Well, these are the concentrations of salt that are in a lot of our groundwater systems around here. We put so much salt down over the years that a lot of our shallow aquifers are just filled with chloride, and we can never use them for drinking water purposes because they're very, very high concentrations of chloride. And you can see here's that above that 200, and anything that's in red is starting to get impacted, and we have all of this groundwater throughout Chicagoland area. And this is really a problem not of rural systems, of urban. So this is an urban groundwater problem. Now, as you know, the groundwater, who is drinking groundwater, if you want to match these maps up, that'd be really cool to see, are we using groundwater here? And generally these are shallow groundwater systems, not the deep groundwater systems we're using. But that's where a lot of our plants and animals are getting their water. So this is really affecting our urban environment by this high concentrations of salt. We're seeing shallow groundwater systems having higher than deeper systems, but we're still seeing increasing amounts of salt in there. So road salt can be a major problem when it comes to that.